A break-even analysis is used for businesses to determine how much sales must be generated in order to earn a profit. Product A will be used as an example to explain the break-even graph. The x-axis represents the output quantity in units, and the y-axis represents the amount of costs and revenues. The horizontal line labeled TFC in the graph represents the total fixed cost. It does not change as the quantity of output increases, because fixed costs are necessary for any quantity of output, whether it's 0 or a million. The fixed cost for product A is set at $50,000. The total cost, labeled TC, increases as output increases, because the total variable costs increase as output increases, and the total cost are total fixed costs plus total variable costs. The minimum amount of total cost and output 0 is equal to the total fixed cost. The average variable cost for product A is set at $2. The total revenue, labeled TR, starts at 0 and goes upwards in a direct correlation. Revenue is price multiplied by quantity sold, so when there's no output, there will be no revenue, and as output increases, revenue increases. This is based on the assumption that all output is sold. The price for product A is set at $5 per unit. The break-even point, labeled BEP on the graph, is where the total cost intersects with the total revenue, meaning a point TR equals TC. The quantity of output at this point is referred as the break-even quantity, BEQ, and the revenue generated to break-even is referred as the break-even revenue, BER. The break-even quantity and break-even revenue is dependent on the break-even point. The break-even quantity for the product A is 17,000 units, and the break-even revenue is $85,000. When total revenue is greater than total cost, a profit is made, and when total revenue is less than total cost, this results in a loss. The margin of safety is dependent on the product's level of demand in the market. It is calculated by subtracting the break-even quantity from the level of demand in the market. For example, the level of demand for product A is 20,000 units, where the break-even quantity is 17,000 units. That means product A could produce 3,000 units less and still would not make a loss if all products are sold. Therefore, the greater the margin of safety, the less risk the product carries, as the product would be less likely to lose money, even when faced with unfavorable changes in the market that would decrease sales. The change in price will result in a change in total revenue. Total revenue is the price times quantity, so if price increases, total revenue per quantity will increase, vice versa. The total fixed cost and total cost will not be affected, since price does not affect the cost that needs to be paid. Therefore, if price increases, it will take less amount of output to generate the amount of revenue that will cover the cost, so it will lead to a lower break-even point, break-even quantity, and break-even revenue level. A change in fixed cost will result in a change in the total cost. Increasing the amount of fixed cost means that the cost needed to produce at each quantity will increase by the same level, vice versa. Changing the level of fixed cost has no effect on the total revenue made. If fixed costs are increased, more products need to be sold in order to cover all the costs. Therefore, the break-even point, break-even quantity, and the break-even revenue will be greater. A change in average variable cost also results in a change in the total cost, but has no effect on the total fixed cost and the total revenue. If the average variable cost increase, the total cost per unit increase as well. Therefore, it would take more revenue to cover the cost, hence the greater break-even point, break-even revenue, and break-even quantity. The required output level for a given target revenue can be found using calculations. For example, to find the amount of output needed to generate $15,000 of revenue, using revenue equals price times quality equation, we found out that 30,000 units of product A are needed to be sold. To calculate the output level for a given target profit, the following equation can be used. Suppose the target profit is $40,000. Using algebraic methods to subtract total cost from total revenue, we found out that 30,000 units are needed to be sold to earn a profit of $40,000. Hope this aids your understanding of the break-even analysis.